Good morning, ladies and gentlemen. I'm Wei Kiat from Group 3, who is going to present to you the brief introductions for our mini project. First of all, our topic for this hydraulic project is to prove that the head loss in the pipe, which are connected in parallel, are the same, regardless to the properties, like for example the diameter or the type of the pipes. So, what is actually meant by head loss? According to Wikipedia, in any real moving fluid, energy is dissipated due to frictions, and this dissipation is called head loss. In general, head loss can be categorized into two groups, which are major loss and minor loss. Major loss is associated with energy loss per length of pipe, which can be represented by the Darcy equations, while for minor loss, it is the loss of energy in bands, fitting, valve, and etc. And the total of head loss in a pipe can be calculated by summing both these major and minor loss. So when pipes are connected in parallel form, like in the pictures, they share the same head loss regardless to the properties of the pipe according to the theory. Therefore, to prove that this theory, our group has come up with an experiment which we are going to show you in this video. But before proceed to the experiment, I would like to briefly explain to you the theory of our experiment. According to Bernoulli equations, the head loss in a pipe is affected by the density of the pipe, of the fluid flow, and the elevations of the pipe, the flow rate, and the cross-sectional and area of the pipes, and also the pressure along the pipes. Thus, total head loss will be directly proportional to the difference in pressure between 2 points in the pipe if all other variables are constants. Therefore, in our project, we set up two rubber tubes at both ends of each pipe in order to determine the pressure difference for the pipes, which represent the total head loss along the pipes. If the difference of water level raises for both the pipes are the same, head loss is the same for both the pipes, and our objective is achieved. However, we expect it to be different due to the minor loss in bending and connectors of the pipes. So, without wasting any more time, let's look at how our experiment is going to be.